So I'm just going to go through each question and just help you get started on those. So the first one, it is about graphing and finding the domain of a function and its inverse. So you are given a function g of x, and you're asked to find the inverse of g. So just keep in mind that finding the inverse of a function, the inverse, which is represented by this g to the -1, that's the inverse of g. You can find the inverse by switching x and y. Which y in this case would be g of x. So you're going to switch x and y, and then you're going to solve, solve for y. And that new y equals is going to be your inverse function. So that's how you find the inverse. Then it's asking if the function is 1-to-1, if g of x is 1-to-1, which is the original function, so don't get confused there, is the original function 1-to-1, and what that's asking is, does every x value match to exactly one y value? So graphically, that means a 1-to-1 function has to pass the vertical and horizontal line, line test. So if it passes the vertical line test, that means it's a function. And if it passes the horizontal line test, that means that it's a 1-to-1 function. So on the homeworks, we looked at different types of functions, and just by looking at what your function is, you can kind of think through if it passes that horizontal line test or not, and you can just kind of explain that in words. Then it's asking you to graph the original function and its inverse on the same graph. So label those for me so that I know which is which. And then it's asking you to find the domain and the range of each one of these. So first you're going to find the domain of g of x. Attempt this in any way, but you're going to find the domain of g of x and the range of g of x, and then you're going to find the domain of the inverse and the range of the inverse. Okay. And let me see what kind of, go ahead and say, you need to put this in, let's put this in interval notation. Interval notation is brackets and parentheses, okay? So looking at the second one, we're now graphing inverse functions. So it provides you with the graphs of the inverse of f and the inverse of s. So you just need to copy these down. There's not actually any work involved for you there. And then what you're going to do is draw the graphs of the original function. So they're giving you the inverse, and then you're drawing the graphs of the original. So if you're working with graphs, so up here what we did when we're doing it algebraically is we switched the x and the y values, or the points, and then on a graph you're doing the same thing. So from the original, you're just going to switch x and y, the points. And that's how you would graph an inverse back to the original, or the original back to the inverse. They're just flip-flopped from each other. And then explain the process you are using to draw. Well, just basically gave that away to you. And then it says give the domain and range of the following. So you need to find the domain and range of each of the original functions, and then the domain and the range of each of the inverse functions. So make sure you're looking at the correct graphs for those. And it looks like we want to use, now keep in mind I provided you with a graph, but these f graphs are just points, and the S graphs are actual functions, continuous functions. So your domain and range are going to look a little different. And it looks like I might not have provided you a ton of space here, but since the F graphs are a set of points, it's not continuous. And this was an issue on exam 3. You're just going to list all the points, and same here, because they're just points. But for the S of X graphs, you're going to use interval notation. Which would be parentheses and brackets. Okay, so the next one, it says using the inverse function for composition. So this one, using the inverse function property of composition. So you are using this property to determine whether each pair of functions are inverses. And so this actually didn't show up in the homeworks, this inverse function property of composition. But I believe we did talk about it even on like homework 10. This idea came up. So you're given two functions, f and g. And so what you need to do is, the inverse function property of composition basically says if you compose a function, which means if we find f of g of x or g of f of x, and if these two functions truly are, I don't know why I did that, if these functions truly are inverses, then when you compose them, then you should get x. So when you take f of g of x, you should get x, and if you take g of f of x, it should equal x if they're inverses. So basically, if you compose these functions and you get x, then yes, they are inverses. But if you get anything besides x when you do each one, and it has to work for both, so you need to test both. You can't just do f of g of x, if it equals x, stop. You need to do it for both. I need to see all that work. And so then you just need to say yes or no, are they inverses or not? So that's what you'll do for that one. And there's two different ones that you need to do, so A and B. Okay, number 4, you're using transformations to graph exponential functions. This is something we did hit pretty hard on the homeworks. So you're given a function, and you're just being asked to graph it. So this is where you need to go back to my homework 11A notes, and you need to look at the base function or the parent function for logs and exponents, and then you need to apply transformations, and those transformations are going to be the exact same transformations we've been applying to graphs for the past several cycles. So you need to start with the parent function. I'll just write that down. Start with the parent function. And then 2, you're going to apply transformations. And then it's asking you for the domain and the range of the function. So you can figure that out once you've graphed it, and go ahead and do that. Once again, we'll just use interval notation. Actually, I don't care. If set notation is easier, we'll say set or interval notation. Just make sure you're using one of those types of notation. So number 5 is very similar. It's just a log function instead of an exponential function. And so you're going to basically follow the same steps. Start with the parent function, and then you're going to apply transformations to that function, and then identify the domain and range. And this last one is a table. We had a few of these on the homeworks. This one is a log table. So they're going to give you different values. They'll either give you a or x or f of x. And so you're going to plug those in, and then you might need to rewrite it as an exponential function to be able to solve for the missing value. So once again, check on the homeworks for that one. But I should see work for all of these. I want to see the table filled in, and then off to the side you should show your work for how you solved each one. Okay, so this should at least give you a start on what you need to do. If you did not do any of homework 11, that's going to be a struggle, and you need to spend probably a few hours getting caught up on that today, because this is going to be very difficult for you if you didn't do any of the homework. So if you have done the homework, so you've been keeping up, you've watched this video, and you still get stuck on something, please feel free to hop onto my live line. I'm happy to answer any questions you have. It makes my life a lot easier if you just ask questions ahead of time rather than just like writing down a bunch of random answers and then I have to spend extra time giving you feedback. So if you have a question or don't understand and you've done your part to try and figure it out, please hop on my live line and I'm happy to work through any of these with you. All right, good luck guys, and I'll check in with you later.